All right, to begin our next module, we're going to learn how to solve systems of equations by eliminations. This is called part A because there's a couple different ways we can do this. So on this particular lesson, our goals are going to be I can use elimination as a method to solve systems of equations, and I can identify opposite terms within a system of linear equations. And that's going to help us easily figure out what we can eliminate if you know what opposite terms are. So, some key vocabulary. First off, systems of equations is a set of two or more equations with the same variables. The elimination method is a way to solve systems by adding or subtracting equations to remove one variable. And the additive opposites are two terms that sum to zero. So like 4 and negative 4, 8 and negative 8, 3x and negative 3x, etc. So the goal of elimination. The goal is to combine the two equations so that one variable disappears or is eliminated. This happens when the coefficients of one variable are opposites. So for example, if you check down here, like we have the 3x and the negative 3x. Those are opposites. Negative 1y and positive 1y, opposites. Positive 10b, negative 10b, those are opposites. So we're looking to find opposites so that we can end up eliminating or adding them to equal 0 so they kind of cancel each other out. Okay, so here's our step-by-step process. The first thing we're going to do is we're always going to line up the equations. So if I have a 2x plus y equals 4, I always want, when I write it underneath it, I want the x to be lined up with the x, the y's to be lined up with the y's, and the constants to be lined up with the constants. We're always going to line them up with each other because it's a lot easier to eliminate if you do that before we do anything else. So, second step, we're going to add the two equations together to eliminate a variable. We will then solve the resulting equation. Then we'll plug the value back into either original equation to find the second variable. And we write our solution as an ordered pair. All right, so let's take a look at this problem right over here. First off, are the equations lined up? Yes, so what that means, if I put a little box here, that means the x's are kind of stacked with each other. Looks like the y's are stacked with each other, and the constants are stacked with each other. So those are lined up. We don't need to worry about doing anything with that one. Okay, so I'm going to go ahead and erase. Oops, that's not what I wanted. Go ahead and erase all that. Okay, second, do we have something we can eliminate? Do we have any opposites? And hopefully you noticed that right here, we have a plus 3y and a minus 3y. So if I were to add 3 and negative 3 together, that would turn into a 0. And the y's would be eliminated. So I'm going to go ahead and we're just going to add these equations together. So 2x plus 5x is 7x. 3y plus negative 3y is 0. So it disappears. We've eliminated the y. And then 11 plus 3 is 14. Okay, so we have eliminated a variable. So step 3, we're going to solve the resulting equation. So 7x equals 14. We're going to go ahead and solve that by dividing both sides by the 7. So we're going to divide by 7, and x equals 2. Okay, now we got to find y. To do that, we're just going to plug this back into either one of the equations. It doesn't matter which one you pick. I'm going to plug it back in right there. So I'm going to rewrite it as 2 times x, which is actually 2, plus 3y equals 11. And then we're going to solve that equation. Let's move this over here. And we end up with 4, because 2 times 2 is 4, plus 3y equals 11, minus 4 from both sides, and we get 3y equals 7. I had a brain fart there. And then divide both sides by 3. And y equals 7/3, or if you want to write it as a decimal, it would be 2.3333. So I'm okay writing it either way. So in ordered pair, I would say x is 2, y is 7/3, and there would be the solution to that system of equations. Or if I were to graph those, that's where it would cross, at 2 and 7/3. All right, let's look at another example. Okay, we got negative 4x plus 2y equals 10, and 3y plus 4x equals 15. Okay, are these lined up? If you notice, I put a box there. I have an x and a y in that box. That means no, they are not lined up. So just to make things easier, I'm going to go ahead and rewrite the bottom equation. So I'm going to rewrite it as 4x, because it's a positive 4x. And this 3y was a positive because there's no negative in front of it. So I'm going to write it as 4x plus 3y equals 15. And now I'm just going to ignore this one. Now you can notice I'm lined up. I got my x's as the first term, my y's as the second term, and it's equal to the constants. Okay, can any of those be eliminated? When I add together, the negative 4x and the 4x are going to be eliminated, because negative 4 plus 4 is 0. So it disappears. And what is 2 plus 3? That gives me 5y. And 10 plus 15 is 25. Okay, so I eliminated the x. Let's solve the result. We're going to divide both sides by 5. And we get y equals 5 for the first part of my solution. Okay, let's go ahead and plug it back in. Doesn't matter which one you plug it back into. So I'm going to take this 5. Just for argument's sake, I'm going to plug it into that one this time. And we're going to rewrite this bottom equation as 4x plus 3 times y, but y is 5, equals 15. So I get 4x plus 15, because 3 times 5 is 15, equals 15. Now we're going to go ahead and solve this two-step equation. So we're going to go ahead and minus 15 from both sides. And in this case, that's going to give me 4x equals 0, which means x is equal to 0. Because when you do divide by 4, 0 divided by 4 is just 0. So my coordinate is going to be the x is 0, and the y is 5. And so that is the solution to my system of equations. Okay, let's take a look at 2 more. Okay, on this first one, well, I'm going to change this. I didn't write this one down correctly. We're going to say that this is a negative x plus y equals 2. Okay? So we're going to go ahead and we're going to solve this one. So they're stacked together. So we're good to just go, and x minus x, x plus negative x goes away. So we're adding these. Y plus y is 2y, and 10 plus 2 equals 12. Okay, so if you're asking why did I put a negative there, I forgot to type it in there. So that should have been a negative x from the very beginning. We're going to learn what to do later if I give you something that doesn't have things that are actually opposites already. But for today, we're focusing on if there are opposites given to you. All right, so to continue, we're going to divide both sides by 2, and we get y equals 6. Okay, so now we're going to take this 6, and we're going to plug it into either one. So I'm going to plug it into this one. And I get x plus y, which is 6, equals 10. Minus 6 from both sides, and I get x equals 4. So my ordered pair would be 4, 6. And that would be the solution to that system of equations. Okay, looking over on the right side of the screen. Are they all lined up? They are not lined up. So I'm going to take this 2x and this y, and I'm going to switch places. So we have a positive 2x and a positive y, and the 7 still stays there. So now they are stacked on top of each other, and I can easily see that negative 2x and positive 2x are going to cancel each other out when I add them. So those cancel out, and then 5y plus 1y is 6y, and then negative 1 plus 7 is 6. Okay, let's divide both sides by 6, and y equals 1. Okay, let's go ahead and plug it back into one of the original equations. Well, I think it's going to be easiest to plug it back into this one, because I won't have to do any multiplying like I would if I plugged it back into the 5y. But once again, you can do either one. It will give you the same answer if you do it correctly. So we get 2x plus 1 equals 7. Solve the equation. We're going to minus 1 from both sides. 2x equals 6. Divide both sides by 2. X equals 3. And so my ordered pair would be 3, 1. And there is my solution to my system of equations. All right. So if you have any questions, please reach out. Special cases. Let's go over these really quick. This is similar to what we did in our last unit. So notice on this one, I'm going to add them together. What is x plus negative x? That's 0. It disappears. What is negative 2y plus 2y? That's 0. It also disappears. So I end up with a 0 on the left side. And on the right side, I have 4 plus 6. What is 4 plus 6? That is 10. Okay, everything got eliminated. Does 0 equal 10? No, it does not. Which means, for this particular case, there are no solutions. Remember, you're just going to type NS into your box on the assignment. So come on over here. Notice 3x and negative 3x disappears. Y plus y disappears. So I'm left with a 0 on the left side. And what is 5 plus negative 5? That's a 0. And does 0 equal 0? Yes, it does. So that means there are infinite solutions. Or in other words, it's the same line. And I would type capital I, capital S inside my answer. So if you ever get left where all your variables are canceled out and eliminated, if you end up with a true statement, it's no solution. Sorry, if you end up with a false statement, it's no solution. And if you end up with a true statement, it's infinite solutions. Just add that S there. All right, so I can use elimination as a method to solve equations, and I can identify opposite terms within a system of linear equations. Reach out if you have any questions.